energy is conserved, which means that the energy you have in position 1, I have to add some work to get to energy in position 2. And so work is just E2 minus E1. Just the difference in those two energies. And now we know what those are, right? E2 is going to be minus 1/2 GMM over R1. R2. And E1 is going to be minus, but I'm subtracting it, so it's going to become plus GMM over R1. Okay, and now we can put this stuff together and figure out what we need to do, right? We've got GMM, we have a 1/2, all those are the same, so we can put 1/2 GMM out in front. And then I'm going to have a positive 1 over R1 and a negative 1 over R2. And I can rewrite this, if I like, as the following. If I multiply R2 up there, and I multiply R1 up there, and then I divide by R1, R2, that's in fact the same thing. Okay? But we know what R2 is, and we know what R1 is. It's always the distance from the center of the Earth. All right, so R1 is going to be R of the Earth plus H1. R2 is R of the Earth plus H2. And so finally I can calculate the work. It's 1/2 GMM times R2 minus R1. The REs are going to cancel out, and I get H2 minus H1. And in the bottom, we're going to have RE plus H1, RE plus H2. And now it's just plugging in a bunch of numbers. Okay, and we have all these numbers. This is, of course, the mass of the Earth. That little m is the mass of the shuttle. G is the universal gravitational constant. If you plug in all those numbers, you can double check with me, but you should get 1.16 times 10 to the 11 joules. Questions on that one? Okay, if you're faced with something like this on the final exam, you don't have to rederive the whole equation. You can jump right to here and say the work is the difference in the energy, and I know that the energy is 1/2 GMM over R. Okay? All right. Any questions? People good? Okay. Hello class, Professor Anderson here. Let's take a look at an example of calculating the motion of a boat on a river. It's going to go downstream and then it's going to go back upstream. And we're going to know some things. We're going to know how long it takes to go downstream. We're going to know how long it takes to go back upstream.